present you today how to use Python as a brain for your devices. A brain in the mean of having rules and control all your devices. By the way, I'm Jonathan Schemoul from HackSpark, which is an online shop for electronics and GMS informatics, where we do consulting around basically this. So what kind of devices do you want to control or get data from and to? Lamps, heating and cooling devices, phones, beacons, health devices, everything that can feed you data, even why not your bike, your car, or whatever. Because we want to add intelligence to our devices. Maybe like you are coming home, your phone sends data to your home hub, and your apartment gets ready for when you arrive. And well, because we're geeks, for fun and hacks. So it's basically that you have a lot of devices sending data. Here we will use an MQTT broker, which is just like a messaging broker with channels on which you can publish and subscribe data to and from. We will have an HTTP server to make a bridge between our MQTT server and our user devices, and we'll also have an intelligence server which will be here. All this is proprietary in the cloud of each vendor. So problem is that your light won't work with your heater. Your car won't work with your door lock. That can seem strange, but it can have uses. What we want to do is to stay local, have everything in-house, maybe on a little Raspberry Pi in your house or whatever. And also, a lot of people are using JavaScript. 19% of Internet of Things respondents indicating they use JavaScript and Node.js for development. For server-side stuff, I'm not quite fond of it, and I prefer to use Python. What technologies are we going to use? On the device side, we will use ESP8266, which is a very, very cheap microcontroller. I will show you some in a moment. It's really cheap. You can add Wi-Fi to your device for like $1, so it's nothing. We will use also MQTT, which is the pub/sub broker I was speaking before. We'll also use beacons and Bluetooth Low Energy. I won't cover this part here, but it's also something that can be interesting. So on the software side, we will use the Mosquito MQTT server, which is basically the standard now. There is also a Python MQTT server, which is Python client for the Mosquito MQTT server, and we will use JavaScript for the front end on a little web app we will make, and Python for the web server and the event server. So let's start. We'll install Mosquito with Docker. One line, it's installed. To flash ESP Easy, which is a firmware for the ESP8266 to make MQTT, let's connect to the broker. We import the MQTT library, we create a client, we connect to localhost, which was TT server we created before with Docker. We start a loop and we subscribe here. This means everything. We could also make a better path, but here we want to see everything that happens. Now we add a little callback when we receive a message, get received message stuff each time we get a new message. Let's have some little nodes that are here, the nodes like this one, which have a LED and a button. This LED will subscribe on 3 channels, one for each color. It's PWM, which means pulse width modulation, which means the power you will give to the LED, basically. It's a bit more complicated than that. But so we have our node here, / our node, / PWM, / the number of the pin on this board, command on, and we send the value here. The value is from 0 to 1023 here. We set the value and we send it. And since we subscribe to all the messages, we see here how the messages are sent. So /luminode, /PWM, etc. Let's be a bit more intelligent and have a gamma table for our LEDs. I won't lose you, but it's to have a good color correction. We will we will set our devices in a list and save the states in a dictionary. On our setRGB function, now we'll save the last state. Now, let's make a web app. We will use Bottle, which is just like Flask, if you know. Well, most of you should know Bottle, I guess. We will serve our static file here. We'll just make an index, which is a very, very simple web page, which is just having an ID app here and calling our app/index.js. We will add some new routes. One which is devices view, which will send a JSON dictionary with our device's current state. And we will make another route which will have a post method on /color/device, for example, /color/luminode. And it will get JSON with R, G, and B as 0 to 255 values. And it will just call setRGB and return the current full state. We will make some JavaScript for it using React. Some people might know React here. It's JavaScript, so it's not really the scope of this conference, but make a little component named app, which will have a state of our devices, and will call every 1 second a fetch device function. The fetch device function will call our /device controller, which sends a JSON object containing devices, and we will basically set our current component state to this. Color change will post the color we need. Get color will just return a color for CSS and HTML from an array. This is just a little kitchen. And well, we are making a little widget for each item our server sends us. Create one div here with one heading with the name. And here we will use a color picker widget, which is already made in React, and have change events, etc. But we will just send events when we get them. We will compile this because, as you've seen, it's SCMA 6, which isn't really your regular JavaScript. We had classes and things like that. So we will compile it using Browserify. I won't enter into the detail, but it permits to go from the app.jsx, which was like JavaScript and XHTML, to a regular JavaScript file that can be used by any browser today. Let's run that app. We'll just make a bottle.run on 0.0.0.0, which is for the public. You're using a PathScript server on Power 8080. If we go to see that app, it looks like that. We have 4 little widgets with colors, and we can click on the widget and set the color. I thought about giving a demo of this, but I couldn't put my laptop, so that's just screenshots. But anyway, we can also add some rules to it. For example, if we want to highlight a device, highlighting a device will mean that the device we are selecting will be in green and the others will be in red. That's just an example of a rule you can make in your application. On unhighlight, you put all the devices in red, green, blue, 255 in blue, so it's full blue. My devices that are here are all blue. Here is my rule. I will get, if the message.topic is /mynode/button/state, those devices send this kind of message on the MQTT broker. This is a really dirty code. You shouldn't do that like this. You should like subscribe to the good messages and everything. But it's so we will highlight this device, and if we receive a 0 from a device, it means that the button has been released. We unhighlight everybody. Bad contact. Yeah. Okay. Again, I do it. I release, it's blue. I click, it's green. I can do it on all the nodes. Yeah. So it basically means I'm receiving messages from each of those nodes. Those nodes are only connected to a USB hub for the power. They are not connecting for the data. My laptop is a Wi-Fi hotspot serving the app on the nodes that are connecting to this Wi-Fi hotspot on the MQTT server. So the devices could basically be anywhere in the world, and they will react each one according to another, according to those rules. The good part about this is that you can have a light in your living room and have it react to you coming back home, or for example, if you want to have a good mood in your living room, you can just have something that listens to you, and you say, okay, put the light a bit lower, and it will do it, and you can do a lot of actions, whether if you are at home or not. For example, we can have relays on your heating devices, and if you forgot it on while going out of home, the system will just maybe remind you, and you can say it, okay, turn it off. Another thing is that with MQTT you can have thousands of devices on the same network. With one broker you can have likely 10,000 of devices, so it's really made for a cloud scale. And it's really light. It can run on a Raspberry Pi or whatever little device you have. To go further on this direction, we can use Python on a microcontroller. It exists with MicroPython, PyMite, and others. I don't have time here, but I can show you later if you want. We can add 433 MHz RF devices that you have at home that can just be connected to your MQTT network with gateways. You can add Bluetooth Low Energy devices to get like proximity sensing with beacons all over your home. You can get feedback from the devices, add loggers and graphs for temperature, air quality, pollution. Can be also useful, and it goes on and on. I've made a little plugin-based project, which is kind of like this. It doesn't have the MQTT part yet, but I'm working on it, which is axpark.simpledomotics. It's on Bitbucket. It's a public repository that you can check out. It's made to have your little domotic hub at home, and there is example to make a little alarm with door sensors and things like that. So thanks. You can find this presentation as a notebook. Everything is running from this notebook, Jupyter notebooks. So all the code that is here is working, and you can get it at this address. So, and if you have any question, you can find me on Twitter, and it's also my GitHub and Bitbucket handle. I've also launched a shop to sell electronic devices, and all you need to do this kind of thing at axpark.fr. The question is, if I can explain again how to get the devices run code that I can communicate with. Here I've cheated a bit. I've used ESP Easy, which is a firmware that is already done, that has the function we've seen here. Basically, the ESP8266 is a microcontroller. You can put any code you want on it. There are libraries either in Python, Lua, or C to communicate in MQTT. The firmware I've used is written in an Arduino-like language. Well, really Arduino, because no Arduino can run on it. And I've just put this firmware and configured it. So there is a switch command, PWM are connected. So here I've called that part from here. The nodes listen on /luminode, /luminode2, 3, 4, which are the ID of those nodes. And they listen on /luminode, for example, for this, /PWM, the port number. So I've just sent command via MQTT directly to the microcontroller. So here I'm just making the code on the server side and not on the microcontroller side, but it could also be there. So the question is, how can you secure those devices? Yeah, it's notorious for having really, really poor security. The MQTT protocol, you can have login system on authorization and authentication system to be able to subscribe and publish. And this is some settings you can put on the Mosquito broker. You can say, okay, this guy can connect, this guy can't. This guy can do this thing, and this guy can't. And moreover, if you have a little application server like we have here, you could secure this application server and make it filter what can pass through and what can't. So the question is, how do you connect legacy devices that aren't in Wi-Fi or IP connectivity to this kind of system? There are a lot of projects around this, actually. There is one which isn't in Python, but is in Ruby, I think, and Node.js, if I'm not wrong, in which you can just drop boxes and put links to connect them to MQTT. Basically, you have to have a receiver. For example, for the 433 megahertz devices, which are the most used now on the market for door sensor, proximity sensors, and all that, you can have a receiver for this in USB, just like the RFXCOM or other standards, and make a little app that will be a gateway for it. Or you could use that project. I don't remember the name. I can find it for you later if you want. That will have a graphical interface to make this kind of link. Thank you. If you have any questions.